An example of this complex question can be read here. Can I find a service searching by geographic region? So, next step, how to implement. Filling the original OWS with new classes, new object properties, and new individuals and their relationships. These stereotypes uh, are aligned with the Protege 5.5 2022, the new version of Protege. It's the same stereotypes of Protege. To implement the OWS BR, we took the OWS ontology. It has its own classes on object properties. We have added classes, object properties. We have taken these classes, and we have established all the relationships among among each other, among all the classes. After that, we have filled the ontology with individuals. Each OWL individual from the class service is a specific representation from a specific service, and we have fulfilled all the classes with OWL individuals. After that, we have related the individuals, we have created relationships among them to create a triple repository, being able to be queried by Sparkle queries. So if we want to find a service, we can find another nodes from the RDF graph to reach this instance of service. After that, we have created some data type properties to establish some values from the instances, exactly like the original OWLS ontology. And the result, we can see a picture of the implementation of a single instance of a service. At the bottom left, we have the class service on green, and we have an instance of this class, flight plan. This instance flight plan is connected to a profile, and you can observe this profile is connected to several other entities. This profile determines a multi-criteria way to find from any kind of node of this RDF graph. We can reach this profile with a Sparkle query. For example, uh, what is the profile connected to category A at the center of the image? We have a triple here. If we make a Sparkle query, we can find the profile gamma. If we find the profile gamma, which is a specific instance of profile, we can make another Sparkle query and find at the bottom left the specific instance of the flight plan. It's an RDF graph. It can be queried by Sparkle queries, and all instances of services implemented at this ontology were created like this. We can observe we have several kinds of entities. We have classes. The same color stereotypes here represent classes and their respective Dutch OWL ontologies. We have ontologies importing another ontologies, and you can observe we have a huge set of entities supporting the semantic discovery of this profile gamma for finding the specific instance of flight plan. After the implementation, the competence questions were translated to Sparkle queries to validate the functional requirements of the ontology or to validate if the ontology is responding my question, is answering my questions. And a Python code was run to do the same query of the Sparkle translated. Uh, an example here, can you find a service searching by category? So select the subject using the object property service category and passing as a parameter meta weather information service category. If we consider the before image, we can find a profile like this using this Sparkle query. And after that, we can find the service executing another Sparkle query. A Python code to run this query is simpler than a Sparkle. It's a search method from Python from the OW Ready 2 library. And some future scenarios for results. The implementation of OWLS enables the development of semantic descriptions that can define all web services characteristics in a registry. It allows web service users to invoke and execute them, reaching ordinary goals like asking for flight authorization. The ability to make semantic specifications about web services in a machine-readable level, allowing information systems to interact with those artifacts. We can observe, we can have devices interacting with a graphical interface and software agents consulting this ontology as a web service semantic registry. And we can have an information system interaction, for example, to get a flight authorization. The contributions and conclusions. The main contribution is a new extension of OWL's original technology with new classes, new object properties fulfilled with instances representing the ATM Brazilian domain. We have a triples repository to build semantic descriptions, and it can be queried by executing Sparkle queries. It's different from the traditional WSTL or UDDI, where we have only synthetic descriptions. Here we can make queries on an RDF graph. A new approach to make semantic search and match precisely any requested web services to the Sparkle protocol using a multi-criteria set of semantic search parameters. I have shown on that result image. It's a safe approach to find web services precisely at a low cost using Sparkle protocol. And the authors also realize that any domain can be implemented like this with a low level of customization. Well, my friends, I think I reached my goal to present an implementation of OWS to support semantic web services discovery. I guess I'm ready for questions.
All right. Thank you, Luis. Any question? Any question for Luis? Um,
Hi, thank you for the presentation. So my question is, I mean, for the web services, I'm not sure, I mean, if you are using, let's say, uh, traditional web services or REST services, and if OLS is working with such kind of services.
Yeah. Thank you for the question. The OWLS was conceived to support the descriptions of the SOAP web services.
Yeah.
But web services are universal things, and we can make separate things here. I have implemented a single description, and at this description we have all the characteristics of the web services. We can separate things here to publish, to advertise, to invoke, and to execute web services. And besides, the OWS is is related to the SOAP web services. I think we can we can make those descriptions related to the REST web services too. Actually, that's my idea for my PhD work here. I'm not going to use the SOAP web service. I'm going to use my idea was to use an URI access to implement my description. So the rest fulfill this requirement. So using this kind of description, we can make access to directly to a REST API to a REST web service to also the SOAP.
okay. Well, I mean, I will also ask a question because it is. Okay. I mean, we have another question from the audience.
You thought about addressing Swagger or trying to add ontological extensions to Swagger or something along that line?
I'm sorry, could you just repeat? I didn't listen. Hear some
Yes.
noise.
Have you checked out Swagger? Yeah, as beyond, because SOAP is kind of less in use right now. I think Swagger is kind of on the uptick as far as web services go. And I was wondering if you were thinking about also some on-block extensions to something like Swagger.
No, I've just considered the SOAP and the REST API because as it's a PhD work, I can hug the whole world. I can think about a huge specification or huge require a set of requirements. So I've only considered the SOAP because of the OWS specification and the possibility to access REST web services.
Swagger's for REST, basically. Swagger is the API definition language for REST. So you may want to take a look at it. Maybe for future research.
Okay, I will also add a question because it is very close to my work also. So semantic web services, when it is discovered, you are working on discovering them. But it is not just one service all the time is sufficient. You may need multiple services which needs to be invoked in a particular order or certain, composition of services you need to build for to achieve some goal. So did you think about any service composability or something like that?
Yes, the OWLS has its own classes to specify atomic process and composite process. Uh, they are located at the process part of the OWLS. The process part defines logically how we can access the service at this description. And we have a specific class for atomic process and specific class for composite process. And they are related with object property, considering the spread of a composite process and the union of an atomic process. And I've implemented 24 specific instances of services, and all the process of these services were considered, um, meaning real types of web services for Brazilian aeronautical providers. And yes, I have implemented this situation, atomic and composite process, and you can query using Sparkle queries. What are the composite? What are the atomic process? My idea is to expose that for a web user and in a graphical interface, and to allow semi-automatic and automatic compositions, to give the opportunity for the user to choose my kind of composition, the automatic composition offered by the system, and his kind of composition, his wheel of composition. He can choose he will can choose on the screen what atomic process he wants to execute, what atomic web services, instead of my choose. And yes, I'm thinking about it.
Okay, thank you, Luis. Okay, so we will end this session, this FOMI presentation here because there is one presenter from our agenda is not present, and I cannot see him even now. I will make an announcement here in case somebody is present um, to represent this paper. It's called "Bring Together Model and Business Ontologies for Protective Coatings." Salim Belutar was the presenter. Is there anybody in the audience or the remote participant who wants to present this paper? I think not. So we will move another presentation from John Shah along with his industrial demo. So there will be an extended session for John Shah. So we will start with the industrial demo session, and then I will invite Sean Maria Bulega from Perpetual Lab, and we'll take just a couple of minutes more to set it up properly, and then we will start. Thank you.
Bye, guys.
Thank you.
Thank you.